Hello, this is Mr. Stansbury. I'm going to take you through the 9C notes on function notation. At the end of this, you should be able to say that I can find values of functions in function notation. Alright, so first thing we're going to take a look at is what is function notation. Okay, and it looks like this. Probably not as color coded as this, but this is the idea. This stands for function f, and then the colon, just like before, is such that x, and then this goofy looking arrow stands for is converted into 2x plus 3. So this is read function f such that x is converted into 2x plus 3. Okay. Now with that, what this is really getting at is that we're just saying that y is f of x. So basically we've got this notation here, function f such that x is converted into 2x plus 3 is the same thing as saying f of x equals 2x plus 3, which is really the same thing as saying y equals 2x plus 3. Okay, so for example, f of 2 would be, so finding the function of 2 of any of these three, which all mean the same thing. It's usually easiest to put it into this form here, but you've got f of 2 is wherever you see this, because really we have this f of x equals 2x plus 3, right? So what you're doing is wherever you see an x, now you plug in 2. So this x turns into a 2 as well, and you get the function of 2 is 2 times 2 is 4, plus 3 gives us 7. So the function of 2 is just 7. All right? Let's take a look at another example. And that is example 3 from page 275. It says if function such that x is converted into 2x squared minus 3x, find the value of f of 5. That's not an s, it's a 5. And then f of negative 4. So again, I'm just going to switch it to the form f of x equals 2x squared minus 3x, right? And then I'm going to do f of 5. So wherever I see an x in this one, I'm going to put 5 in instead, like so. So the function, and again, what this is really saying over here, the function of 5. So if you put 5 into this function that's being converted, then you will get this this here, and then we just simplify it. So 5 squared is 25, and 25 times 2 is 50, and then negative 3 times 5 is 15, or negative 15, so f of 5 is 35. Alright, and then let's try the same thing for f of negative 4. So f of x, again, is 2x squared minus 3x, so I'm going to plug in f of negative 4 instead. So wherever there's an x, it now turns into negative 4. Alright, so f of negative 4 is negative 4 squared is 16 times 2 is 32, and negative 3 times negative 4 is plus 12. So f of negative 4, 32, 42, 43, 44. Alright. Okay, one last example, or set of examples, is from example 4 from page 275. And that says if f of x, so it now has it just in the plain old function notation here. So if f of x equals 5 minus x squared, find in simplest form f of negative x and then f of x plus 2. So same thing, f of x we know is 5 minus x squared. So now we want to know f of negative x is. So just like we did on the last set of examples, wherever we see x now goes negative x. Oops, negative x squared. So f of negative x, in this case, is going to equal 5. And then we have minus a negative, so it's really 5 plus x. And then negative x squared is x squared, so then we'd actually have to put this negative on, so we get minus x squared. So that would be really as simple as you could get it. You can't combine anything here, so we just leave it like that. And then this one here, it's got a little bit more to it, but not too bad. F of x, again, is 5 minus x squared. So again, now I don't want to know what f of x is. I want to know what f of x plus 2 is. So all these places that have x, I'm going to put in x plus 2 instead of x. 2 squared. Okay, so f of x plus 2, the 5 doesn't change. I'm going to distribute this negative to both of those, so I get minus x minus 2, and then I'm going to subtract this x minus 2 squared. Now again, you got to actually FOIL this x plus 2 squared out. So x plus 2 times x plus 2. You got to FOIL it or stack it. Alright, x times x is x squared, x times 2 is 2x, 2 times x is 2x, and then 2 times 2 is 4. So this all combined together gives us x squared. The 2x and the 2x give us 4x, and then plus 4. And then also note that that's got a negative in the front, so you got to distribute that negative to all three pieces here. So f of x plus 2 is 5 minus x minus 2 minus x squared minus 4x minus 4. And then our last step is just to combine like terms. I always like to put my x squareds in front, so there's my x squared, so that's going to go in front, and it's negative x squared. So I like to circle it and cross it off, so I make sure I don't forget anything. And then we got negative x and negative 4x. Give us negative 5x. Those are gone. And then 5 and negative 2 is negative 3. Sorry, 5 and negative 2 is 3. Minus 4 is negative 1. So then that's what we get for f of x plus 2. Alright, and that's it. If you have any questions, please ask. Thanks.